my dear VLSI aspirants, welcome to Deep Silicon VLSI YouTube channel. In this video, we are taking one example and explains how logic optimization can be done. Because you know guys, VLSI means design optimization. You need to implement the design with less amount of hardware, isn't it? Yes, without any delay, let's dive into the question number 15. Let x is equals to x1, x0 and y is equals to y1, y0 be unsigned 2-bit numbers. The function f is equals to 1 if x greater than y and f is equals to 0 otherwise. What is the minimized SOP expression for f? That's it guys. Whatever you are watching here, the red color one is the question. That's it. Now we want to get the minimized SOP expression. What is the design requirement? The design requirement is f is equals to 1 if x greater than y, otherwise f is equals to 0 only. Now guys, here x is equals to x1, x0, y is equals to y1, y0. They are unsigned 2-bit numbers only. Hence, here as there are 2 plus 2, 4 variables, then we will get 16 combinations. To optimize the time, I have written the truth table combinations already. Okay. Now, let's enter into the design requirement. When f is equals to 1, if it is x greater than y. So, in these cases, x is 0 only, hence output is 0. In this case also 0, 1, it is 0, 0. Now, x is greater than y and remaining all the cases, here it is x less than y only, hence all zeros. Again here x is greater than y, here x is greater than y, here x is equals to y, here x less than y. Similarly here 1 1 0 0 x is greater than y, here x is greater than y, and here 1 1 1 0, then obviously it is x greater than y. And this one x is equals to y, then it is 0. This one guys, hence now if you see what are the minterms, then obviously this is 4 and this is 8, 9 and 12, 13, 14. That's it. These are the minterms. Hence, if you map into the SOP like a K map, because we are expecting SOP expression. If you map them directly, you know guys, this is 0, 1, 2, 3. This is 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So we mapped. Now let's simplify. If you simplify the expression, see this is one quad. If you simplify, what you get? x1, x0 bar gets cancelled, y0 bar gets cancelled. So it's a y1 bar, x1, y1 bar. Again, there is a pair here, so that it is x0, this one y1 bar, y0 bar, and here there is a pair. Therefore, here you get like x1, x0 and this y1 bar gets cancelled, it's a y0 bar. Hence guys, the minimized SOP expression as per the design requirement is f is equals to x1 y1 bar plus x0 y1 bar y0 bar plus x1 x0 y0 bar. This one guys, this is the minimized expression. In this way, if it is a big logical expression as per the requirement, you can minimize the design. Okay, so I hope you like the video. Please guys, subscribe our YouTube channel Deep Silicon VLSI and extend your support. Sure, we will give you the best of the best. Only one thing from you is please support and please give your honest opinions. Right? See you in the next video. This is Shivaram signing off. Jai Hind.